Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths B. We have started our discussion with the chapter Circles. What did we learn? We started with the basics of circles and the next tangents, right? We also find out this equation of normal and so on, right? Today we are going to discuss the conditions of a a straight line is a tangent to the circle. Okay. In what conditions that a line is behaves as a tangent of a circle, or else what is the relation between two tangents, what is the angle between two tangents, okay, and what are the different formulas of equations of tangent. Okay. See here, as a part of that, the first question is, show that the condition for a straight line y equal to mx plus c touch the circle, let us say x square plus y square equal to a square is this. Okay, that is, he gave a circle of radius a. What is the center for this circle? 0 comma 0, isn't it? Then he is telling that find the condition that this equation touches that. Okay. What do you mean by the term equation touching? That is nothing but this is the tangent of a circle. Clear? So, let us assume some point, let P be a point. Okay. So, if I want to find the equation of a tangent from a point P, what is the formula? Tangent equation is S1 equal to 0. Yes, that is nothing but x1 plus y1 minus a square is equal to 0. Yes, this is the equation of tangent. Now, he is telling that this also touches the circle. So, what do that mean? This equation and this equation are nothing but the same. Okay. Let us say this as equation 1 given y equal to mx plus c. Let us write it as mx minus y plus c equal to 0. Let us take it as equation 2 touches circle. Clear? What do this mean? These both equations represent same line, that is 1 and 2 represent same line. So, the ratio of their coefficients must be equal, that is x1 by m is equal to y1 by minus 1 is equal to minus a square by c. So, if we consider, I will directly read as x1 as minus a square m by c, y1 as a square by c. Is it right? Therefore, the point P is minus a square m by c and a square by c. Clear? Then this point passes through the circle as well as tangent. So, we can substitute this point either in this equation or in circle equation, anything is fine. Okay. So, let us substitute that point in that equation. Okay. Then we will get it as a square by c is equal to m into minus a square m by c plus c. Clear? So, what do we get here? A square is equal to, let us cross multiply c that side. What do we get? C m into minus a square m plus c square. So, this is nothing but a square is equal to c m square a square plus c square. So, c square is equal to a square plus a square m square c. Okay. If I take c, a square common, I will get it as 1 plus m square. Sorry, here we should not get c, right, here they will get cancelled. So, it is a square into 1 plus m square. Clear? So, the thing is, condition you have to remember is, if a circle touches a tangent which is in the form of slope intercept form, then the condition is c square is equal to a square into 1 plus m square. Clear? So, From this, what can I write equation as standard equation of tangent? Y is equal to mx plus here c is equal to under root a square into 1 plus m square, that is nothing but, let us write it as standard r. A is nothing but radius, right? 1 plus m square under root. Since it is under root, I will get it as plus or minus. Clear? That is a equation of tangent formula when slope of a tangent is given. Clear? Once again, equation of a tangent to the circle with radius r, okay, and having a slope m is nothing but y is equal to mx plus or minus under root of r into 1 plus m square. Is it clear? Did you understand? This is one form. And not only this, there are a few more formulas we have to remember is length of chord. Let us say if this is a chord, okay, and the perpendicular distance from this center, let us say it as d and the radius as r. Therefore, the length of chord is given as 2 into under root r square minus d square, where r is radius and d is the perpendicular distance of a chord from the center. Is it right? That is length of chord. And one more formula is, if there is a circle, it has two tangents from a particular point. Okay, let us say making some angle theta, then the condition is tan theta by 2 is equal to r by root s11. What is r? The radius. S11 is S11 from this point. Clear? These are the basic formulas and we are going to do problems on this formulae. Clear? Shall we start? Let us do. Look at the next question here. He is telling that find the equations of tangents to the circle and parallel to this. Parallel to this means which form we have to do? That is, from this we can get the slope of equation. So, the equation of tangent will be, we can simply tell it as slope form, is y is equal to m x plus or minus r into 1 plus m square. In the previous formula which we discussed, the center was, what was the center? Origin. Here the center is not origin, therefore the formula will be x plus f, I mean y plus f, and here it will be x plus g. Yes, is it clear? There we directly go ahead as y is equal to m x plus or minus under root r into under root of 1 plus m square. Yes, here since the center is not origin, we will add f and g. Clear? So, first let us write the what is center. Center is 2 comma minus 3. Yes, and the radius is under root 4 plus 9 plus 12. It is root 25, r is 5. And here from this, which is nothing but minus g minus f. Here g is minus 2, f is 3. Yes, so let us substitute all the values in the given equation. That is it. Therefore, my equation of tangent is y plus f is equal to m. First of all, what is slope of this? Slope of that is minus 1. Yes, minus a by b, isn't it? Minus x coefficient by y coefficient, that is minus 1 by 1 is minus 1. That is minus 1 into x plus g is equal to r. What is r? 5. 5 into under root 1 plus m square. Yes? Yes or no? Here it is plus or minus. Clear? Once again check. Y plus f is equal to m into x plus g plus or minus r. R is 5 into under root of 1 plus minus 1 ka square. So, let us simplify this, that is y plus 3 is equal to minus x plus 2 plus or minus 5 1 plus 1, that is y plus 3 plus x minus 2, right, plus or minus 5 root 2, that is nothing but x plus y plus 1 plus or minus 5 root 2. These are two equations. One is x plus y plus 1 plus 5 root 2, x plus y plus 1 minus 5 root 2. Clear? The only condition we have to remember is this formula. Clear? Y plus f is equal to m into x plus c plus or minus r into 100 of 1 plus m square. M is slope, g is f, I mean g and f are coordinates of our center. Clear? Shall we move on to the next problem? Let's do. Look at the next question here. He is telling that find the equation of tangent to the circle perpendicular to this equation. So, the same formula we have to use, that is equation of tangent in slope form, that is y plus f is equal to x into, I mean m into x plus g plus or minus r into under root of 1 plus m square. Okay. So, what is m here? M is minus 3 by minus 1, which is 3. What is perpendicular slope now? Minus 1 by 3. Yes, that is m1 m2 is minus 1. He is telling perpendicular. So, we have to find the perpendicular slope. Clear? And the next is we have to find the center. Center is minus 1 comma 1, which is minus g comma minus f. From this g is 1, f is minus 1. Okay. Here minus 1 comma 1, minus g minus f, g is 1 and f is minus 1. And the next, what is radius? Radius is under root g square plus f square minus 1, which is nothing but root 5. Let us substitute in the formula. What do we get? Y plus f is equal to m into x plus x1 plus or minus root 5 into root 1 plus m square. Clear? That is minus half x plus 1 plus or minus root 5 into, this is under root 1 plus 1 by 9. Clear? That is nothing but we can take LCM there, minus x minus 1 by 2 plus or minus root 5 into under root, here it is 9 plus 1, that is root 10 by square root of 9 is 3. Isn't it? Let us take LCM, then I will get it as 3 2s are 6, 6y minus 6 is equal to minus 3x minus 3 plus or minus 2 root 50. Clear? Let us bring all together, then I will get it as 3x plus 6y and 3 minus 6 is minus 3 plus or minus 2 root 50 equal to 0. Is it right? Is it not easy to solve? Fine. Shall we move on to the next problem? Let's do. The next question here we are going to discuss is find the length of a chord of a circle, this equation. Okay. What is the formula for length of a chord? That is, if this is a circle, if this is a chord and this is center and this is D and the radius is R. What is the formula? That is length of chord is 2 into under root R square minus D square. D is perpendicular distance from the center to the chord. Yes. So, let us write the center and radius. For the given equation, the center is 1 by 2 comma minus 3 by 2, right. What is radius then? Under root 1 by 4 plus 9 by 4 plus 22, isn't it? So, I can write it as 1 plus 9 plus 88 by 4. Yes, this is nothing but 98 by 4, 89 plus 10. Clear? This is the radius. So, what about the perpendicular distance? Perpendicular distance formula is ax1 plus by1 plus c by under root a square plus b square. Yes. So, let us substitute this point in this equation. What do I get? Mod 1 by 2 plus 3 by 2 minus 3 by under root a square plus b square, that is 1 square plus 1 square. Clear? So, here if I take LCM or else directly write 3 by 2 plus 1 by 2. How much is it? 4 by 2. That is 2 minus 3 by root 2. That is nothing but d is 1 by root 2. Clear? So, let us write length of chord is equal to 2 under root r square minus d square, that is 2 under root. What is r? 98 by 4. What is d? 1 by 2. Okay. So, this will be 2 under root 98 minus 2 by 4. This is 2 by 2 into root 96. Is it right? So, after cancelling 2 and 2, I will get the answer as 96, that is nothing but root, how much is it? 96 by 2 is 48, 48 by 2 is 24. So, I can write it as 6 into how much? 6 into 16. So, this is nothing but 4 root 6 units. Is it clear? Did you understand? These are all the different varieties of problems of our circles and the questions based on the chord of length of a chord and the tangent equation and so on. Clear? Fine. This is for today. Let us meet in the next session with more problems of circles. Thank you.